Let's look at this list of numbers. This list is called a sequence because it's predictable how to get the next number. 3, 8, 13, 18, 23. You can see that each term, each number, each item is 5 more than the one before it. So from 3 to 8 is 5, from 8 to 13 it would be 5 more. So we call that the common difference. That's why we use the letter D. So it's the difference, how much we have to add from one to get to the next. We're going to call the first term a sub 1. So the first term is 3. You can see that a sub 2, the second term, is found by taking the first term and adding 5. A sub 3 would be the first term plus 2 5s. So we got 3 plus 2 times 5. And the fourth term would be the first term, which was 3. And we're adding 1, 2, 3 5s. So to get the fourth term, we're adding 3 5s. You can see a pattern developing here. The fifth term is found by taking the first term and adding 4 5s. And the sixth term would be 5 5s added on. Well, this pattern leads us to a formula, and the formula goes something like this. To find the nth term, n being whatever number term you want, if you wanted the 10th one out, here we have 6 terms listed. The 7th term would require us to put a 7 here where the n is, a 7 over here. You'd have 3 plus 7 minus 1, which is 6. 3 plus 6 times 5. 3 plus 6 times 5 would be 33. So that would be the next term. And that is actually the term. So that formula right here, a sub n equals a sub 1 plus n minus 1 times d, it's not, the formula is very useful for other problems that involve arithmetic sequences. So this arithmetic sequence has this formula. It involves knowing the first term and knowing the difference, how much they differ by. What if we were told that we had an arithmetic sequence, but we're not given the sequence and we need to generate it? But we are told two things about it. We are told that the 8th term is 25 and the 14th term is 43. Well, using the formula, putting an 8 where the n is and then putting a 43 in, we get these two equations here. So we get a sub 1 plus n minus 1 times 8. 8 minus 1 is 7 times whatever d is, and then on the with the 14th term it'd be 13 times d, and we get these two formulas. Now, using a little bit of simultaneous equations, in other words, I'm going to take this equation right here and I'm going to subtract this one from this one. So if I subtract these two, I get 18 over here, the a sub 1's cancel, and I get what's left would be 6d equals 18. Dividing by 6, we get d equals 3. So now we know that d is 3. We can use the 3 back into the formula. So if you want to put a 3 right here, you'd get a sub 1 plus 7 times 3 equals 25. I think you could see that a sub 1 would have been 4. You could do that yourself, put in the 3 and work out the arithmetic there. So if I have the first term is 4, and I can now predict any term I want, I can generate the entire sequence.